Okay, we're live. Hey everyone, let's give some time so everyone can join. And thank you for.
It's not transmitting yet.
Oh, there's a little delay.
Yep.
That's fine, but we're live. um, so thanks everyone for joining our meetup webinar, and we'll start shortly. Just a few housekeeping announcements here. So this is not like a regular webinar. Um, so we encourage your participation. So if you have comments, it's more like I don't know, kind of a podcast ish. So if you have comments, if you have questions, you can leave at the chat, and we will do and we'll highlight your comment. Let me show one example. Thank you, Mark and Igor, for organizing this. Ruchi, thank you for joining. So that's how it's going to work. So if you have question, comments, let us know. Um, and we'll try to keep this more informal. It's more like a conversation. But of course, we'll present stuff. And the idea of this is not only to present AutoML. By the way, AutoML is half of the presentation. It's what we usually not cover when people talk about machine learning is the steps that we take before, which is more than 50% of the task. So what we need to do to get AutoML ready. So, okay, so people are joining. Mark, you want to comments? You want to say anything before we officially get started?
Let's just check the audio. Can you hear us well? I was monitoring here. Looks good, but I think you're all good. Let me see if I can hear myself. 1 second. So
I can hear you fine. Okay, so yeah, so
I think
can you guys
yeah,
hear us?
there is there's a big delay. Okay.
Yeah, there's a delay in this platform. This is common. There's a I think 10
Yes.
seconds delay. Okay, so we got answers. Okay,
Yes.
pretty
If
good.
you have any questions, you can just type the questions. We try to keep this informal, like a more like a chat. So
Hmm.
don't if you have a question in the moment, just fire the question and then we try to answer as best as we can. And this one is a little bit different because me and Igor we are uh, trying to mimic what is a real environment when we are dealing with AutoML. So I'm more like the data engineer behind the data, and Igor's more like
Hmm.
the scientist and the researcher asking for data. So I don't know exactly what he's looking for because I don't have all the knowledge behind it. So Igor, I actually was asking Igor, okay, what do you need? How you need it? And then we did this kind of experiment, so it was very interesting for myself because I learned what's the difference, how is different between having a data for a regular ETL for data analysis where you just need to get the data, do some data treatment, and that's it. And for AutoML is way more challenging, not technically speaking, but how you have to relearn how to deal with data is a little bit different. You need more knowledge to do that, and you have to research. That's pretty much it. So the ETL itself is easy, but it's very challenging to know how to define the target. Target's actually okay, but the features are very challenging. How you understand the features. So you talk about that in this webinar in more details, right?
Yeah, yeah, it's exactly like Mark said. I gave him the requirements, just like I would do to a data engineer, and then with the requirements, he then provided me with the data I need. um, which is interesting. We try to make this as interesting as possible. So I don't have anything prepared. The idea is we build live. And I didn't look. That was part of the challenge. I didn't look at his data, but I trust him as a data engineer. Um, so that's the whole mistake. No, I don't think so. I know you quite well. So that's the experience. So we kind of doing this live. So that's why we want to do this more informal. If you have comments, questions, we're always looking at the chat. Before we begin with we have a few slides. There's a little bit of theory to understand why we're doing a few things. But before we start, there's a QR code here. We'll bring it back at the end. It's not going to be available the whole session because we'll show you screens, PowerPoint, but you can join. We have so this is a join, by the way, this is a join meetup event. So we're doing for Atlanta, Boston, Portland, Dallas. And but people from other meetups elsewhere, they're also welcome. So we have this meetup WhatsApp community for all of the US and Canada meetup groups. So if you're in the US and Canada, if you're not, you're also welcome. But specifically, if you are from one of these locations, scan it, and we'd like to continue the conversation after this session. So
Yes.
then we can all exchange knowledge and ideas. All right.
Yes, the meetup groups, Qlik meetup groups are returning. So you see a lot of new meetup groups. So if you have 1 year where you live, just join it. You may have the opportunity to have a in-person event. So those are the best ones. And then we have multiple online events like this one. Maybe you're not near a city. You can create your in your own city if you have the willing to. So you can contact us. We can help you how to set up a Qlik meetup group, and then you can also participate on online meetups. So I'm a member of maybe all meetup groups we have here. Maybe not all of them, but so you always have the online ones. So even if I cannot travel to Brazil or any other country to join an event, I have the opportunity to attend to an online event. So just be part of it. Um, just look for Qlik Meetup if you Google it, or if you look in our websites, you find easily the link to join a meetup group. All
Yeah.
right.
Okay, so let's get started. So usually, um, usually um, we have a session where we discuss what's new in Qlik. We're not doing this time just because you guys can see the slides, right?
Mhm.
We're not doing this time just because we have a lot of content to show.
Yeah, it'll
So
be 3 hours event. Yeah, just to talk about the
yes,
new stuff.
yeah, exactly. So we'll discuss AutoML today, but in action. The idea is to make things as close to a live AutoML implementation as possible. And so this is very um, just very summary version of what we've seen. We've seen more than this. So we'll have like three ish demonstrations throughout um, the session. So first, we'll start with Mark Costa doing all of the data preparation for machine learning as a data engineer, and then
I
he
see
have the.
someone. Sorry about that. I see Heidel. Sorry. He's having problems to join. I tried and it worked. So we can check with you later about the WhatsApp link. Why
Yeah,
you're not able
I'll paste the link as well in the chat in a couple of
Yes.
minutes.
So go ahead.
So then we have a demonstration. Then jump to my part where I will show the machine learning AutoML stuff. We had already meetup meeting like our previous one was about AutoML, but focus on language
Mhm.
capabilities. So we did like the sentiment analysis with Qlik AutoML. Now it's focused on the process of implementing AutoML. And then I have a demonstration which I will split into two demonstrations. So I'll do a little bit demonstration, little bit of theory, a little bit demonstration, more theory, and then the end of the demonstration. Okay. So having said that, oh yeah, and before we start, we would like to thank our sponsors, Qlik. Of course, is a Qlik meetup. Qlik gives all support for us to make this happen. And IPC Global, we both work for IPC Global. Marcos and I. Marcos, I forgot to. It wasn't in the first slide. I forgot to mention. Marcos is our director of DevOps and Data Ops, and I'm director of Education and Data Science. And IPC also support us, help us with everything we need. All right, so having said that, Mark,
Good.
take it away.
All right. So I would just hide us, not now, but in a few seconds. So the first thing we have to start with data preparation, and like I said, data preparation in this case it does not start with the ETL itself. It starts with the research of the subject you are studying. So let's move here. And so here are the steps we have for machine learning. So one, like I said, is to identify the metric value to predict. So what is the target? What you're looking for? What you're trying to predict? So is the sales amount? Is the customer churn? Is the cardiovascular disease, CVD? So this is the one that we're studying in today's event. So you'll be the CVD. So that's the target. So for the entire data set you're going to prepare, you need to specify one target. What you're looking for. So what is the value? And that changes the whole thing. You can have the same data set, but if you change the target, you have to change the whole data set that you have. You have to prepare in a different way. So for this one, CVD, you have to study CVD. What are the things surround CVD? What matters? So it doesn't matter if I live in Alaska or if you live in a different country. Doesn't matter if I'm overweight, if I have a healthy life, or if I just if I have a PlayStation 5 or an Xbox. So we have to start understanding what we have to take in consideration. So just telling those possibilities, you just listen to that. Okay, if we have a PlayStation 5 or Xbox, it doesn't matter at all. But if it's overweight or not, that probably matters. What about the age? Does that matter? Probably. So that's the step two, the investigate and research. So find what is relevant to that target. So our focus here is CVD. So we have to understand everything about that. And this is a very important. It's highly recommended also speak to a field specialist. So this is something probably most part of the companies will learn in the hard way. They have AutoML, they have a lot of automated stuff and say, oh, good, anyone can do this. Just put the data there, we'll process it, and you get the results. We get the predictions. This will not work. So you need a specialist. You need to understand what you're doing. You need to learn how to aggregate the data, prepare the data, and do every single step carefully to get a good prediction. It's not just about throwing data and see what happens. So you have to understand what you're doing here. In data collection, finally, it's the inventory of data. So, okay, I know everything about my targets. I know what the data that I need to collect, but do we have this data available? So what I have available for me And does it matter? So is this good data? So we have to work with what we have. If we don't have in our current system, we have to, okay, how can I get more data to support our analysis to do a good model for our targets? Okay. And Igor, if you have anything to add, just you can interrupt me. Okay. And okay, and those are the basic. So this is about researching. So what are the questions you need? So what do I need? So what you're looking for, and what data do I have, and what data do I have to obtain? Sometimes you have partially the data, but if you know, this is small, I know, but this is about CDC, by the way. So if you're missing a fundamental part of information, how good will be the targets that we have? How good will be the prediction? So if the weight is very important, plus the age, and if the patient is a former smoker or not. So maybe you're not able to do the prediction. Thank you, Richie, with what you have in hands. So maybe, okay, I don't have this data. Maybe I have to collect somewhere else. I'm not sure, Igor, if you're missing some features, if it's enough to just abort the project in this case. Do you see it that way?
No, it depends. It depends if sometimes the data it's really hard to obtain, and you need like extra budget. I remember there was a customer of ours like many years ago before Qlik AutoML, which we had to do it all manually in R. Want to predict electro outages, and very important piece of data, because it was the main reason for power outages, was like lightning striking trees.
Mm-hmm.
Um, so they need like information about the trees in the city, like the density, etc.
Right.
So
Yes.
that delayed the project quite a while, because then you need to find information. It's not available. Oh, so what should we do? Should we get like satellite images and do computer vision to it?
Yes.
Sometimes it gets really complicated. Um, so you need to understand, and sometimes you don't have that. Some piece of data is not as important, so you go anyway. But then uh, you need to understand that, well, maybe I not
You
cannot
have to be aware.
extrapolate. Yeah, I cannot extrapolate this, or maybe instead of predicting through like the next year, I can only do 6 months. So you need to
Mhm.
do adjustments as you go. So you need to work in parallel with the field specialist. In this case, it's medical research. You need to work with the physicians. Um,
Perfect.
and so, yeah, we're not replacing those professionals, where we're working in partnership.
So we have two other questions. Will using talent data preparation help? Yes, yes. This will be. We'll talk about that in the next slides. How current are various data sets show here, and how do you determine what to use or ignore? Yeah, those are good questions. So maybe Igor, can you talk more about that? So which
Um,
ones you can ignore, and if you have
yeah.
various data sets show, okay, go ahead, Igor.
So it all depends on the target, and we'll talk about that when I'll discuss some of the something called the machine learning framework. So it all depends what you're trying to predict, and what is your horizon of prediction. So let's say I'm trying to predict if a person will. Let's say a very simple example. If I'm trying to predict if a person will die, this is a very easy prediction. It's 100%, because eventually, if you give enough time, 100 years, whatever,
Yeah,
everyone will die. So
never
that's not
fails.
doesn't help anyone. But if I want to say I want
Mhm.
to check if the patient will die during the hospital stay or in the next year, then you have a horizon. How much the data is important to that. So if I had like a specific disease 20 years ago, it might be important if it is a disease that has long-term effect. But if I have a disease 20 years ago that has no long-term effect, then it's not important. So it depends on the actual information you're dealing with. So then that's why it's important to research the literature. That's my starting point. And not only medical research, by the way,
Mhm.
any research. Let's see what knowledge we already have. I don't need to reinvent the wheel. Let's see what kind of knowledge, what other people found, so then we can continue. And then we'll identify. This is an example. There's a in
Yeah.
the image in the middle. There's a bunch of information here, and then I can read that. Oh, this researcher used this information. Then I
Mhm.
talk to my team, like physicians. What do you think about that? And they say, oh yeah, no, but is doing this just because he's, I
Yes.
don't know, studying the generics impact. We're not doing that, so we don't need this, but we need that. So and then we'll decide, and then
Even the effects of new medicines and new technologies. So how can that affect? So if you have a
yeah.
disease 10 years ago, maybe now you have new medicines, so you have advanced medicines that prolongs
Hmm.
your life or just cure the disease. So
Yeah.
everything can affect, and that's how also why you have to adjust your model time to time. It's not something that, oh, I did my AutoML model, that's it, so you're good. No, you have to keep revisiting and upgrading it and adjusting it. Igor you talk a lot about that in
Hmm.
his part. Okay, let's move next. Good questions. So then we have the target defined. So what you're trying to predict. So what's your object of study? It's one field, okay? And then you have the features. Features are like are the fields, but are prepared fields. So what are the fields that matter for your data model? So we call these features in the context of AutoML. So a feature is individual measurable property of characteristics of a phenomenon being observed. Features are the input variables to the machine learning model used to take predictions. So I can, and this happened to us. I have loaded a lot of fields, and I know some of those fields will not be used, but I give to Igor anyway. But he can pick the ones that matter the most, and the ones that I know, okay, those are important, are the ones that I treated. I reduced the granularity of the fields. We'll talk more about that later. So I had prepared some of them that I think, okay, those are the ones that matter the most. So those are probably will be the features that Igor will pick during his analysis. But I pull out of them. So maybe you have a field that will not be a feature, but it doesn't matter. You can reduce your fields uh, during the AutoML configuration. And then we have the types of measure. I'm not sure if Igor lost his connection or not, but let's keep going. So the
No, I'm
type,
here. I'm here. I'm
okay,
here. Yeah.
types of feature. Uh, so we have the numerical features, continuous value like age, salary, temperature, categorical features. I think those are one of the most important ones. So those are discrete values like gender, product category, or country. I have adjusted a lot of the numerical features to categorical features in my example, and the time features. Okay, let's move next. And the feature engineer, this is very this is very important. So this is where you're going to jump from a simple ETL that you just get data and do it to actually transforming that to something useful and important for your AutoML model. So it's just how it's a kind of ETL. It's if you look at if you get a load script and just or any any transformation you did, you say, okay, this is just a regular transformation, but you have to think about what you're doing to transform a field to a feature to a feature. So they call this feature engineering. So feature engineering is the process of using domain knowledge to create new features from raw data that help machine learning algorithms perform better. So now at this point, you need to be conscious about why you're doing transformation, why that way, why that matters. So you need to have in mind already your target. It's impossible to do this part without knowing the target and what you're looking for. Otherwise, it would be just random transformations. So enhance the predictive power of machine learning models by providing more informative inputs. And types of feature engineer is feature creation, generating new features from existing data. So you have a bunch of fields. You can combine them in a different way or transform them to create a new field. So this field will be eventually a feature. Feature transformation modify features to better suit the machine learning model. So even if we provide to Igor the initial, okay, this is what I think will be useful for you, he can return that. You need to adjust this feature to have this kind of information or reduce the granularity of the data because it's not meaningful. It's not helping the study. So then you have to adjust that feature or even create multiple versions of that feature so you can pick different ones during your model. Feature selection, yeah, it's related. So choosing the most relevant features for the model. So it's just because you have lots of features about in your data set, it doesn't mean you have to pick every single one. And more doesn't mean necessarily better data. So you may be adding noise to your AutoML value. So your target will be affected if you're adding a lot of features that, okay, that doesn't matter. Or if you have, let's say you have 20 rows in your data set and you have 200 fields, that's, oh, okay, this is not helping at all. So this will not create a good prediction. So don't blame the AutoML if you're having a bad prediction. Maybe you have to research more, get better, design better features. So design better your input. Okay.
And we'll show a few examples here, guys, in the process when Mark is doing his demo and also before. So.
Mm-hmm. Okay. And these are some examples. So not all the numbers are the same. This is very important. So the blood pressure, the difference between 118 and 19 is the same as 19 and 20 plus 1. But they have different meanings, okay? We should engineer a new feature, blood pressure range. I think I did this one. Yeah, I think so. So then just having the numbers, the range, it maybe it's not meaningful like in this case, but you'll be better to classify the blood pressure as normal, elevated, hypertension stage 1. The same thing is
Can I give just a little context on the medical context here?
sure. Mhm.
So what he means by this is basically this. So think machine learning at the end of the day will be in a mathematical formula. So the module will come up with a mathematical formula, what the weights, etc. So if you provide as an input like blood pressure, a numeric value. So when he says that difference between 118 and 119 is the same as 119 and 120, it's just one. So 119 is
Mhm.
one more than 118, same as 120 to 119. So it looks like the difference between a patient that has the 119 blood pressure and 219 is the same as 19 to 20. However, it's not, because if your blood pressure, like systolic blood pressure, is up to 119, it's still normal. But you add one more, then you consider
Yeah.
elevated. So that's why using numbers do not help your machine learning, because it does not provide that information. So then instead of using number, we're doing feature engineer. We're creating a new field that has then categorical information. Then we have the levels, because
Yes.
then it captures that difference. So that's what Mark means when he says not all numbers are the same. So that's the medical perspective for this, and we can find similar things in in many other examples in many
Mhm.
areas.
Yes. Age group is also a good one. Uh, and there are some other examples summarizing. So calculated total number of purchases made by a customer in the last year to predict future purchasing. So you don't need every single purchase of the customer in order to define to get the target. You can summarize that. So this will help better your model. So sometimes you just don't need all the tiny details of your data. So when you have that chance, just summarize it. Combining features, create a let me hide it. Let me hide us. Create an interaction feature by multiplying age and incoming to study the combined effect on spending behavior. So you can combine multiple features to create another feature to have a better improved feature. Log transformations, applying a log transformation to skewed data, like income to normalize its distribution. Sometimes when you have a log curve, it's better to identify the patterns and have a better numbers for your feature. Polynomial, I never used this one. Generating polynomial features, example age elevated to 2 to capture linear relationship. Yeah, those are not. I never used this one, but these and this one for sure. And you see that on this example, not summarizing, but this one for sure. All right, let me put us back. Wait, okay, let's move next. We are back. I hope that haven't muted us. This will be funny. Okay, time for demonstration. Let me get the correct screen. Okay, I have to move these things around.
Yeah, I
Reconnect.
think we should hide us. Maybe we need to hide us again.
Yes, yeah, maybe not now. So, okay. So to create the features,
Before
and
I'm sorry to interrupt. So, guys, you
Mhm.
have questions, comments, keep them coming in the chat, and let's make this interactive. So feel free to ask questions,
yes,
comment.
yes, I'm looking that way because my screen on that side now because I have to show mine. So we're keeping. Okay. Right. One step back. So, so when I have a chance to start exploring the new Qlik features, so this one is the script. So this script is like a Qlik Sense application without the UI stuff. So you just have the code part, and I think it's pretty cool. So I'm getting used to it, and I'm using. So if I have a QVD builder or anything to do just data transformation where I don't need to see data relationship, like in a data model, I just creating data. I use this script. So it has a lot of nice features. Like you can see the input. So what data it's going in your process, what is going out, and the name of the tables, the rows. And if you click here, you can see the data lineage, the impact analysis. So there's a lot of nice stuff. You can see all the notifications, reload the history. If you have copies, publish it. It's kind of nice. You can reload from here, or you can check the load script. So this is the load script. And moving back to Alan's question, can I do this in Talent? Can I do this? I don't know about QCDI, but Talent, yes, you can do the same kind of transformation using Talent. You can use your database scripting. You can use any ETL tool that you're familiar with. I prefer this to do in Qlik because I'm more used to it. And Qlik is a integrated platform where you can access your data to collect everything. You can mix different sources, and you can save in different formats. And you also have the ETL platform. You can integrate everything with automations. So this was natural choice for me to, okay, let's do this in Qlik. It makes sense. Okay, so I keep in the same platform, so I don't need to be switching different platforms. A little bit about the structure and a little bit about good practice. So usually we keep all the mappings in the same section of your code. So let me hide this. So here is everything that I have identified as a good feature where I should replace numerical values with textual values. So here, like you have the sex, period, BP meds, curse smoke, educational level. So instead of numbers, we have values, diabetes, and a lot of other information. Okay. And then everything under the exit script, I'm not considering. This is for other stuff. So then we have our study data. So the source of this, my entire thing, is this Framingham data.csv. It's a text file that Igor made available for me. So then I get this one and I start, okay, so based with Igor's request and some of the information that I had, so this, I just mark it here. This would be my target. The CVD is a cardiovascular disease. So that's the target. And this would be 1 or 0 at this point. And then we have all the data. So I was not sure if this would be needed or not. So this is from the data, just numbers from the data source. I just list in here. I rename some of them just to make more user-friendly. And I have prepared some of the data to take care of the formats. This is very important. And it's one of the feature engineer that I think we haven't talked about, but we will. And then I was mapping some of the values. So, okay, if I have sex, how I would like to transform it to a more meaningful value. And good. Let me see if I have a good example. Like sex is a good one. So it just, yes. So sex 1, 2, it doesn't mean much. But if if I say men or women, it have more meaningful information, like the meds and the smoke status. Okay, so this is about that, mapping those values. And then also here was dealing with ranges. So if we have this field here, this is cholesterol. If it's under 200, 125, so instead of having like the whole range from 1 to 124 listed in the value, I just put low, normal, or high. So this have to be based on your research. So how can I define high cholesterol or a normal range? So you have to study that and define the correct range. Same for age, that changes. So do I have to do the range for in an interval of 10 years, 5 years, 2 years? So you have to understand based on your research what matters, which range matters for your target. This is about the BMI, okay, and glucose, and that's it. So, and another feature, new feature that I was using this study was to save as a Parquet file. So if you don't know, Qlik now supports Parquet both on Qlik Cloud and Qlik On-Prem. So Parquet is a data format that's also compressed. It can be really fast to load in your data model, and it's open. So any platform that supports Parquet, you can share that file. KVD you can only consume in Qlik platform, but if you have a Parquet or CSV file, any other text format supported by Qlik, you can share that data. So in this case, I was using Parquet, and that was especially interesting because of these guys here. So if I preview the data, I think this is available also in the application. So you can see some of the values here. Oop. It's taking some time. So you can see the CDC and all the other values. This is not interesting to me. I can just, okay, let me just take a look. But what matters for me is this. So 2 things: you should avoid as much as you can null values. So just try to avoid that. That doesn't help your data, your model. I think Igor talk more about that. Um, yes. So if you have a high density of null values, you may, okay, this, maybe I should not consider this as a feature. You have to handle that in a different way. And I'm looking for, let me see if I can, what's the field name again? This one, TOT cholesterol. Where is it? I can't. Okay. So this is one good example. Just for this 500 sample, I have 150 distinctive values. And then this is show one of the values. But I have treated this value right here. So remember, we should not have a high granularity level or a high density of possible values in a feature. So instead of having this, and this is not be meaningful for this study, I have created this cholesterol range. So instead of having 150, I should have around 3 or 4. So if I have cholesterol, so this in this case is just 2, maybe because it's just a sample data. But then we have reduced it from 150 to just 2 values and more meaningful values. So it'd be probably low or high or low or normal or high. So this can improve your model, your AutoML model. And one thing about Parquet, and that's very helpful here. So we know that in Qlik, the type of the field can be text or number. If Qlik does not know if it can, oh, this can be a number, but I also have a textual value in the same field, so I don't know how to define it. So you have a mixed data type. If you have a mixed data type, this will be null. So you don't know what is the data type. So in my model, everything was identified as a string number. A date is just a number, okay? But if you don't have it defined, it will not be flagged. And this is also doesn't help your AutoML process. So if you bring a data there that the AutoML, okay, is this an numeric value or what is this? Parquet is radical. It's just, if you don't have a well-formatted field, it's just, okay, I will not store anything. This field will be just blank. So not have any value. So those are some of the fields that I had to specify because Qlik was not sure about the format. So I have to specify that. Those was a little bit more problematic. So I tried to convert to a numerical value. Sometimes I still having null values. So then I just use the alt function. So when I try to convert a numeric value and it doesn't, I just, okay. So if you're unable to convert, just say 99. That's it. So I did this for some of the values. So these are the kind of data preparations that I was taking care of. So reduce the granularity of the data to create ranges, more meaningful ranges. Make sure the data type is correct. Avoiding the null values. So it's just, okay, if you have a lot of null values, we're trying to ignore those fields, not even bringing them here. And then I adjusted save as a Parquet file and say, Igor, go ahead. That's the data you have to study. And I think that ends it, my demonstration. All right. Let's go back to the slides. Okay. Good. Let's move next. Now it's about Qlik AutoML. So this is where Igor, I hand the data to Igor and okay, let me use that. Yes, have fun with this. And if you have any problem, just let me know. I can adjust the data and you can check again. All right, Igor, it's on you.
All right. So this is a classic slide. I'm not going to spend too much time on it, but just we'd like to start from the beginning. When we talk about AutoML, the ML of AutoML means machine learning. There's this classic definition that is written here. It's a branch of artificial intelligence that you recognize patterns in historical data to predict future outcomes. There's another version of it that says it's a branch of artificial intelligence where you learn from historical data to predict future data. However, I like a different definition for machine learning. Actually, we released a few weeks ago a video where I talk about machine learning, etc. It was a, I think, 8 minutes video. And the definition that I like the best is you learn from historical data the relationship within that same data. So then you can understand what might happen in the future. It looks like the same definition, but there's a small chance because there's a small difference because I put the finding the relationship first and then the prediction. And I'll talk about that more in a few minutes. So if you have questions, most of the questions you have, if you have data, you can answer with machine learning. Like, will the gym customer cancel their membership? That's a classic customer churn. What is the expected lifetime value for a given customer? There's a classic type of regression. And this is just kind of, it was taken straight from the Qlik help explaining the process within AutoML. So we start with an experiment, and I'll explain in a minute what an experiment is. And then I can do multiple experiments. And then I use different algorithms to find those patterns. Once it is trained, I have a module, and then I can make predictions. Don't worry if you do not understand what I just said. I'll explain this in more details. Basically, that is machine learning. That like fancy term. That's basically what it is. Now, machine learning exists to solve or to answer multiple types of questions. AutoML specifically can answer two types of questions. We can say three because one of those two we can split into two different types. But basically, it's designed for classification and regression. In classification, we have two types: binary or multi-class. So what is a classification? Basically, it's a machine learning that can predict, let's say, will my patient develop this disease? I have two options, yes or no. So then that's a classification, and it's a binary classification because I have two options. What is the outcome for the patient in the hospital? Well, the patient can be transferred, the patient can be discharged, the patient can die. So I have multiple. So there's a multi-class classification. And same as what type of category should I put this customer or this product? Could be multi-class, binary classification. And then we have the other type where it's the most complex one, and which is a regression. We're predicting a number. So what will be the average price of, I don't know, housing price of this area within a year? And then that's a regression because we're predicting an actual number. There's a few limitations. So basically, of course, binary classification, the distinct values you're predicting has to be two because it's binary. Easy. Multi-class, of course, has to be more than two, otherwise it's binary. So it has to be three, but up to 10. Why? Because if it is too many, I have like 11, 12, 15, 30, whatever many classes you have, it cannot make a prediction because for each one of those classes, you need enough sample size. If you have too many, you rarely having enough sample size. So, well, but my variable, my target variable that I'm trying to predict has, I don't know, 15. What do I do? Consider grouping some of them together. Oh, these two are very similar. Should I group them together? So it's another option. And then regression predicts a number, but you have to have at least 11 different distinct numbers within your data set. Otherwise, they're so similar, there's not much to predict. If you're predicting, let's say, how much, I'm trying to predict the throw of a dice. This is a very silly example, a throw of a dice. But the dice, like a normal dice, has only 6 possible values. You have to use a multi-class classification, not a regression for that, not predicting the number, because we only have 6 categories. You need at least 10. So, this is a thing that it's hard to teach, because a lot of things you get from like experience from doing it, and working in collaboration. When you get like the statistical data science training, you get a lot of these insights, a lot of this experience throughout the process. But then work with and as a team, as a group, then you can get those insights. Now, those are the types of problems AutoML can solve. A question that we get asked a lot: how about time series? It does not. And a lot of problems, they are hidden as a time series, and we don't understand as a time series. I'll give you an example. Let's say I want to use AutoML to predict how much disk space I'm using for my QVGs, because I want to say, oh, within 1 year, how much disk space I need, so then I can buy more hard drive, whatever, considering I'm not in the cloud, for example. So if you're in the cloud, you don't have that problem. Great. But let's say you do have that problem. Oh, it's a regression. It's a regression because I want to predict a number, the size. So I provide all of this data, and then AutoML does not perform well, because that is not a regression problem. That's a time series problem. You know why? Because the size, considering I'm not deleting anything, the size that I'm of disk space, or the size of my QVGs tomorrow, depends highly on the size of my QVGs today, and today depends on yesterday, because it's growing, just like a stock price. What is the chance of a particular stock being $100? Well, if the day before is 99%, it's pretty big. If it is 80, it's not as big. So there's a time series component, because the importance of each feature, it's not the same. Each feature are more important as they are close in time to your target.
And by the way, a quick comment, that was one of the data sets that we're studying to add to this webinar. So I had this
80% of this preparation was finding what data we're showing.
Yes. I think we tried 4 or 5 different data sets.
Most of the data sets, they are too simple, so no fun.
Yes. No fun.
Some of them are too complex, that require a week.
So and then I finally got. I was sleeping, and then I woke up. Oh, we have this data set, and this would be nice because it's one of the products we support that tracks the growth of the data of KVD files and the ETL performance of the layer 1 KVD builders. But then they go, oh no, this is a time series. So what that means? So that
I mean, we can do time series. Don't get me wrong, but not in AutoML. Yes. We do more
not in
manual
AutoML
approach. Yeah. By the way, a little, just because I found the opportunity. If you go to Mark and I, we have a blog. We'll give you the link at the end, called Data Voyages. I have a video where I show how to use Fourier transform to find patterns, pattern on trending in data. Fourier transform is one of the best techniques to use, mathematical techniques we use for time series. Anyway. Now, let's go. I just have those 2 slides before my first demonstration. So I'll do the first demonstration. I have more slides, but I want to get started our AutoML project. And I'll use the data Mark prepared for me. But I'm not, and while, so we'll get started. We'll leave the AutoML training going. And while it's training, I'll go back and we'll discuss a little bit more theory. So let me jump to my screen. So that's our cloud environment. There we go. So before, I'm not sure if you're familiar with the new layout of the cloud environment. But before, we have the green magic button, like the add new button. So I would, if you still have like the old one, you will click like the add new and find experiment, ML experiment. Now we have this, which is cool. So I can go to create. I actually like this better. I think it's better organized. And then I have all of these things I can create. Like the script is the one that Mark was showing you, but I want to do a machine learning experiment. All right. And I will discuss in after this first piece of demonstration specific what an experiment, deployment, etc. is. So let me click now. I have the green add button, like this plus sign here. Now, to start an experiment, there's only one thing I need to give it a name. So let me call this AutoML CVG. Let's call mid-up July 2024. So remember what we're doing. We can save this in a space. I'll just save my personal space because this is just for personal use. But of course, we recommend saving this in a shared space so other people can collaborate. And I'll open the experiment after I'm finished. There we go. So Qlik will guide me through the process. And the first thing I need to find is a training data set. So that's the data set with historical data that I will use to train my module. So let me go to the specific space we have for the meetups, which is, let's search for meetup, Qlik meetup, and I will find it's something study data, cert data. There we go, that's the one. So that's the Framingham study data, Parquet, our data sources from the Framingham heart study. So no real, I mean, this is real data, but no personal identifying information here. So this is data we can use for this purpose. So let me click on it. Once I click on it, then Qlik AutoML will read the data and will give me some valuable information about the data. And I'll explain some of these in a minute, but let me just give you an overview. So this is all of the data I have available. All of the columns. And if you scroll down, you will notice that for each one of them, you'll identify the type of the data and the feature type, which are two different things. So I'll give you an example. Education flag. That's basically your education level. So I have is an integer because it's a number. The possible values are 1, 2, 3, 4. And the feature type is numeric. By the way, this is wrong because it is a number, but it's not treated as a numeric. It's just the number is just a code. So I can come back here and change this to categorical. Those are categories. So treat them as text, not as numbers. So don't put them as like in mathematical formulas directly. Those are some work that needs to be done before. So you can see that and make that treatment if you want to. Actually, I don't need it because I'll use another field that has the actual categories for education. But just giving you an example. So I have all of these. Sometimes you have a few columns that are grayed out because they cannot be used. Let's say we have a column that has only one value for every single row. It's useless. There's no variance. So then it's grayed out. You cannot use it. Now, we have a very good question here. Let me pop up from Ruchi. Can you combine several Parquet data sets in the ML experiment? The answer is no. For not only AutoML, all the ML tools, you need to provide one file. So that's part of the data engineer, people like Mark Costa work. If you have multiple files, you need to combine them into one table, save as one file. That's how Qlik AutoML and any ML tool expects it. Okay, so I have all of this. First thing I need to find is my target. What am I trying to predict? So I'm trying to predict cardiovascular disease, CVG. I have two options here, the numeric and the categorical one, because I know this is a categorical. It's basically, are you developing cardiovascular disease within the next 5 years? That's the problem that I'm trying to answer, the question, yes or no. So I'm picking this one. So I basically just need to click here, then Qlik picks that as my target. You see the little target icon here? There we go. That's my target. And then Qlik automatically identifies that as a binary classification. Great. I'll come back here in a minute. Let's discuss this fuse. Now, all of the fuse, with a few exceptions, and we discussed why, they are selected. So these are features, and Mark discussed features as well. So basically, those are the columns that are not my target. The columns that are will be used as an input for the model to learn. However, I cannot use all of these columns because some of these columns will confuse my model. Some of these columns are not meant to be used in my columns. And once I explain in the theory, like what is the machine learning framework, what is target leakage, etc., then you have a better understanding. But a little spoiler because I want to unselect some of these. This, for example, this is an ID. This is an ID. So I'm not providing, I cannot use an ID. Oh, because you have an ID is an odd number, then you have, no, it makes no sense. It's not helping me to predict that. So I'm removing that. Also, I have 3 columns for sex. If I'm providing 3 columns for sex, it's the same as providing 1 because they basically providing the same value. So let me pick the categorical one because this is a categorical one. Total cholesterol is another example. My creative cholesterol range for me, so I don't need the number, so I can unselect that. Same for age. Actually, age, I don't know which one will make more sense. So let me bring it to, and then let's see the model to the side. And then I have like this current smoker. I want to do this. I want to remove these 2. How many cigarettes per day someone smokes? This is the original one. This is another one. So this, yeah, doesn't matter. They're basically the same. Now I have a few here that are excluded because I have too many distinct values. So it's not going to add anything in my range I want. So I'm going to remove some of these. Actually, I want to remove this, skip this. Now, there's a few. I'm not going to do all because that will take more time. But there's a few here that are important to remove. This prediction will be made when I have some type of information, some level of information. So let's say I want to decide if a patient, I want to not decide, I don't have the power. I want to predict if a patient will die or not. I will predict if a patient will die or not. That's okay. So if I'm predicting if the patient will die or not, I cannot provide the date of death because that means I'm telling the module, I'm cheating and telling the module, hey, this patient died. But if the patient is alive, I don't know if the patient will die or not. I don't have the death, the date, the date of the death of the patient. So that information comes from the future. I don't have any information from the future. Like I want to see if this patient will have high cholesterol, and then I cannot have something that is they only know for patients that have high cholesterol. Like if a patient is taking a specific medicine, the only patient with high cholesterol take. So any information that comes from the future that you only have if you know this, like if you know that your answer, then you cannot provide it because you already know the answer. And when you need to make the prediction, you don't know the answer. So like the prevalence, actually, this I want to bring it because this means that if there are people in the family with that. So
I'll
yes,
move our, oops. I'll move us to the side there.
good, good, good,
Okay.
good.
Yeah, so people can see the whole screen.
Yeah, and all of this time, I'll also remove because they mean what and death, patient die. I mean, um, it's all information I'll have in the future. If patient has any cardiovascular disease, well, that's what I'm trying to predict. So that's we call target leakage. So I want to avoid all of that, and that's a very common trap for people to follow. A lot of people say, I don't need a data scientist to do Qlik, and every time I hear that, I don't know. I want to jump through the window. Oh, with this, you just with a few clicks, you don't need a data scientist. And then people said, oh yeah, great, yeah, I don't need a data scientist. And then they do all of that. Look, my model, I have 95% accuracy. Great. In training, having 95% accuracy is easy. I will just provide data from the future. And then you put into production. By the way, you don't have no idea how to put in production because there's a lot of concept involved in terms of machine learning operations. But then your production accuracy drops to 30%, which is less than throwing a coin. Um, and then why? Well, because you actually need a data scientist, but now you don't need a programmer to do the machine learning. But then you can work in collaboration with the data scientist. And also, instead of 10 data scientists, you need 1, 2 data scientists to do the work. Now, I have all of this. Now let's discuss this a little bit. I'll leave it running, and then I'll show a little bit of theory, what actually going on the back end. So that's my target. CVG, great. Now, once I click run experiment here, what Qlik AutoML will do, basically at the end of the process, because there's a few preparation steps that I'll discuss soon. Qlik AutoML will learn how all of these columns that I have selected correlate to one another, having CVG, cardiovascular disease, as a target. How all of those influence the development of cardiovascular disease. So Qlik AutoML, I'm not providing any medical knowledge. Qlik AutoML will find, based on the data that I have, maybe I'm missing data, so then I'm only good as the data I have. But that's what we do. Now, how does a machine learning learn those different rules, like the rules of the game? How does machine learn how these variables correlate to one another to affect the prediction? Well, there are multiple ways to do that. Each way, we call it an algorithm. It's like, let's say I want to do ribs, I want to cook ribs. How can I cook ribs? There's so many recipes to do ribs. So each recipe is an algorithm. The actual ribs prepare that I can eat is the model. So if you go to other tools in the market, they will do similar work. However, they will try 20, 30, 50 different algorithms. And actually, I saw, and some of them I'm actually certified, so I can really say from experience, I'm certified in all of these very, very famous tools. And they'll say in the sales speech, oh, Qlik AutoML, they only testing 8 algorithms. We have 50, 60. Yeah, great. And then the algorithm they have selected are one of these. They use neural network. They use a lot of things. But at the end of the day, these are the ones that will be selected because there's a lot of other algorithms that do not apply for this type of work. Like, there's no need to use neural network deep learning for classification for regression, because you get, like, I don't know, 0.1% more accuracy and 6 more hours of processing. It makes no sense. It's like, oh, I have this fly to kill. Let me get my, I don't know, my nuclear arsenal to kill a single fly. It makes no sense. So these are the ones that will get the job done. So that's one of the reasons that AutoML is so fast. Now, now the algorithms make my brain hurt. They're pretty beautiful if you nerd enough. The mathematics behind it, I recommend, like, the actually boost the math behind it. It's amazing. But anyway, what AutoML will do will train we'll train the modules using this data for every single one of these 8. I can unselect some of these 8 because I know, for example, this is not a Bayes kind of problem. So I would select, but I'll just let it run all. But in order to do that, Qlik AutoML needs to perform a few tasks, and those are what we talk about, the AutoML pre-processing. I'm not going to discuss them here. I'll discuss in my slides because I want to let this run. So once I'm running, it will perform all of these pre-processing tasks and do the training in all of those, and it will compute how well each one of those algorithms did, and then recommend you the champion for you. While it is running, let's go back to the slides, and let's a little bit more theory, and I think I need to hide us so we can see all. Oh, there we go. This is the one. Got it. Okay, now some of the things I already discussed. Just a little review. Experiment is where you do these things. Is where you ask AutoML politely, because sometimes eventually AI will have conscience and might revenge people that are mean to AI. When I see people like kicking robots, like the Boston Dynamics robots, don't do that. They will remember. Anyway, jokes aside, it's where the machine learning will learn the rules. After it's learning, after the process is completed, the process that I'm running right now, I can deploy that to production. Means I can use this and we'll do that task. Now, oh, by the way, before we do anything, Qlik AutoML do some feature engineering additionally to what the data engineer did. Like, for example, if I have a time feature, like I have a date, Qlik AutoML will automatically create an year, month, week, day of the week fields automatically, and other little things. And also the data pre-processing. I show you 5 steps there. I'm not sure if you can see well my image here. So if there are columns with no values, Qlik AutoML will do the imputation of nulls, which it could be how accurate these calculations are, as accurate as if you're doing in Python or in other tools technologies. By the way, on the back end, AutoML runs Python scikit-learn libraries. So it's industry standard, but everybody does, or a lot of people do. Also does encoding categorical features. Encoding categorical features like this. Let's say you have you're predicting something about cars, and you have the color of the car, and let's say you have 3 options: black, white, red. You cannot provide those values as a text to the machine learning, because you can. AutoML will convert that. But AutoML, the algorithms will not be able to do anything with those, because those are text. And at the end of the day, remember, we'll have a mathematical formula. So we have to convert that to something numerical. So the most common scenario is, well, instead of have 1 column for color, we'll have 3 columns, 1 for black, 1 for white, 1 for red, and then the value will be 0, 1, 0, 1, identifying if the car is one of these colors. I'm old school. I used to do all of these programmatically. You have to do that all programmatic. It's a lot of work. Training all of these algorithms, all preparation in Python or whatever it is. It takes time. Trust me. Feature scaling. Sometimes you have 2 numerical values. Let's say the price of a house, which is in the hundreds of thousands, maybe more. And then you have the not square feet. Now, let me get, I don't know, the temperature, average temperature, I don't know, whatever information. So one is like, a temperature could be like 50, 60, 70. It's a small number. The price is too big. If you just input the prices, the data as is, the prices, just because it's a big number, will have a bigger influence. So then we need to feature scale. Instead of just showing the number, you show a scale of the number. I don't know, difference from the mean or something like that, percentage, right? Those different techniques. Automatic holdout of training data. So Qlik will not use all of the data I provided to train. It will use some of the data, and we'll do like a sampling, and then we'll hold some of the data. And then after all of the algorithms is trained, you run that again, and then it will do like the five-fold cross-validation. We'll do like 5 times this process, so then it validates to see if the data is not overfitted. So that's that. And then there's another thing that we don't recommend you to do when you're training for the first time, only if you want to optimize, is what we call the hyperparameter optimization, or HPO, which is basically the way algorithms are learning are based on parameters. No module is perfect. No module will predict something perfectly 100% of the time. It does not exist. There's always error. But its error is better than not knowing anything at all. There's always an error. So in order to get to the actual training, so let's say I want to predict this specific whatever I'm predicting, like cardiovascular disease. So let me adjust my weight, my variables, 0.1 by 0.1. Good, very precise. Will take you hours. Well, let's try to make it faster, but that will be good enough. Let's do zero point 0.5 as zero point 0.5. So that's what we call like learning rate. Then it trained. So, okay, now my model is trained. This is my model with a champion, the one that was chosen. Great. Now, let me then take and do a hyperparameter optimization. Let's try to, instead of zero point 0.5, let's try 0.4, see if we get better. So these are some of the things that it might help your model or not. Now, by the way, we are almost actually the training is done. We're almost done here, and I'll go back there to show what we did. Oops, not this. This, sorry. And when we saw the data before the training, there's a few the different insights Qlik AutoML will give. I'm not going to read all of these, but for example, if AutoML says there will like a little bit of warnings. If AutoML says your data is sparse, there's too many null values, so AutoML cannot use it. If it says it has high cardinality, it cannot be used. It means like it's like an ID. Oh, I have so many distinct values. It's like an ID. It doesn't help me to find the patterns. Um, or if it is one hot encoded, it means that it's a categorical column that has less than 14 unique values. And so that's how, remember the categorical, I forgot the exact term, the encoding categorical features. The way Qlik AutoML will do depends on if it's unhot, encoded, or impact. It depends on how many different values you have. Is a little or more constant. The column has the same value in all of the rows, so I cannot use it because there's no variability. So this is some information you will
Just
find it.
let me comment. This is very interesting because you can deal with the feature engineering during the data preparation part. But even though Qlik will, you can improve your data or you can change it in a way that, so it's kind of a safe net. So even if you did something wrong, Qlik will, be careful with those values. So if you don't have your data perfectly well done, it will let you know that you can make some improvements, and you can pick which field will be a feature or not. So this is very interesting.
Yeah.
Okay.
Now, this I will discuss soon. So let's go back here. Let's go back to my screen. And there we go. So now I left one column that I should remove on purpose because I want to show you something. Look at my model. I have, let me go back. Actually, no, up. The one means 100% accuracy based on F1 score. 100. Great, I have the perfect model. I told you I don't need a data scientist. I'm doing better than a data scientist. Yeah, right. Providing the target. So I had another column that has CVG. You providing that. So you're providing the answer. Now, everybody knows the future if you provide the future. So this is a module I cannot use because it's useless. Because if I'm trying to predict if the patient will have cardiovascular disease, I don't know if the patient have cardiovascular disease. But don't worry, I left this on purpose. So what do? I left it by mistake, or maybe something I didn't know. So I can create a new version. Look at this. I can create a new version, and then in my new version, I can come here, get my features, and I can unselect that one. And then I can click run, and then Qlik AutoML will do a version 2. So don't worry if that things like that happens. You still can work. Okay, so this
Quick
is run.
question, Igor. Can you, so let's say you have multiple versions and you have did a lot of complex feature selections as settings. Can you change different versions? Is that possible? If you want to hold back one of the chains, is that
Yeah,
possible?
I mean, I still have version one here. So if I don't like version two, I can go back to version one. Yeah, unless you delete
Oh,
version
cool.
one,
Hmm.
which is this button on the bottom right here in red. Unless you do that, then yeah, no problem. Okay, so it's training all of this model will be finished in a minute. Let me go back to the slides again while it's running, so we don't need to wait. Now, let's discuss some important um, terminology and some important concepts in machine learning. And that concept is what we call machine learning framework. Okay, machine learning framework. So, machine learning framework it's a combination of different concepts that are important. I would say even mandatory for us to implement machine learning, like to really implement machine learning. So one of them is event trigger. Like my machine learning module, it's not running all of the time. It's not running like it's not real time. There is one moment in time where I run my machine learning. There is an event that triggers the prediction process. It could be, I don't know, 3 days after the patient is it's admitted to the hospital. It could be every beginning of fiscal year. It could be something, but there is an event. There was a date that happens. There was We do these webinars about machine learning. I don't know how many times we did so many times in presentation demos, etc. And one demo that I use it a lot in many scenarios is this one called the patient readmission. And this actually it comes from a true use case was actually implemented in different places. Will the patient, after you discharge the patient goes back home, will the patient come back to the hospital within 30 days? I need to predict that before the patient leaves the hospital. So while I still have the patient, so I can treat the patient better. But when? It's when the patient is admitted, it's in the middle. So I need to define the event trigger. So most hospitals is like, well, it's when the doctor said, oh, this patient will be discharged within the next 24 to 48 hours. So there's a flag they mark in the system. So that is the event trigger. When that happens, the data then for that patient will predict what is the chance of the patient be readmitted. Okay. Another very important concept that I find people who are not trained in machine learning, they get at that wrong um, quite often is the data role. If I'm predicting something for a patient, or it could be for a machine, for a customer, for whatever it is, all of the information needed needs to be in one row. I saw examples. I'm predicting something for a patient, and I have the data for that patient for the last 10 years, summarized year by year. So one patient has 10 rows, and you're never able to predict that. So it has to be one row. So instead of having 10 rows, you have to like do like the opposite of cross table, kind of pivot table, and put it in one row. So that's another thing. A target, Mark explained, was a target is what you're trying to predict, but a target has two components. The outcome is the actual value you're predicting. Like here, we're predicting the patient will have cardiovascular disease or not. And then we have the horizon. Okay, the patient will have the cardiovascular disease in 5 years, in 1 year, in 2 years. You need to define that. Like the readmission, the patient will be admitted within 30 days. So if the patient goes back to the hospital after 2 months, it's not a readmission. It's outside of our horizon. You need to understand that because you need that information to prepare your data. So in my training data, when I have the CVG column, the patient had CVG or not, It's not a current information. It's like the patient had a CVG up to 5 years after the data was collected. So that's horizon needs to define. Now the features, Mark discussed the feature. I think everybody understands what the feature. And then we have a prediction point. Prediction point is the time where you stop collecting data and you're ready to make a prediction. So otherwise, because if you pass the prediction point and you continue to collect the data, you're getting data from the future. So if I need to predict if a patient, let's say I want to predict if a student will graduate high school, and I want to know after the first year, after freshman. So if I need to stop collecting data after freshman for the machine, I mean, I can still collect data for other purposes, but for the machine learning purpose, I need to stop collecting. Otherwise, I'm getting data from the future. There's a future leakage or target leakage. So that's your prediction point. When do you want to stop your prediction? That's a fine balance you need to discuss with the business people, because there is a balance between accuracy as more data as close to your target. Let's say I want to target if the student will graduate high school. As close to senior year as I get, more accurate I get. But at the same time, I reduce my actionability. That's a difficult word. Actionability. We all pretend that I said it perfectly. So your ability to act. So if I get it too close to senior year, my ability to act, because no, maybe it's too late, is small. So then I need to balance. If it is too early, I cannot predict that once the student is like 5 years old, but I cannot predict that when the student is already senior year because it's too late. So you need to balance what is a perfect prediction point. All right. This is very, very, very important. And then example of machine learning framework. It's part of your proposal. It's part of the document you send to business people, data engineers. It's part of your project plan. I've seen so little projects having this. Like, oh, I want to predict if a sale lead will close, will be a win. Like I will actually win the sale. Okay, that's your target. What is the event trigger? Well, I want to start. I want to make my prediction. I want to run the machine learning when the sales lead is created. Okay, it could be, or it could be after the first meeting, after the POC. You define that. What are the features? What data do you have available? I have this, and that. All right. What is your prediction point? Well, prediction point is 30 days. Actually, this is the 30 days after the lead is created. Okay, so I will collect data for 30 days, and then I'll run my prediction. And what is your question that you're actually asking? Predicting 30 days after lead is created, will that lead convert to blah, 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 blah. So that's your question. All right. And then the student graduation is the example I gave it before. Now, this I'll show later. Let's go back to my screen. And this, there we go. Now, I ran in parallel a third version. So that's the third version. So that's my model. Okay, that makes more sense. Patient had a stroke. I'm not considering that as a cardiovascular disease. That's my main feature. Look at this. It ran all of these algorithms, and it has all of these metrics for accuracy. If you want to understand what all of these is, at the end of this presentation, we'll give you like a link for an ebook that I wrote that explains all of this. So let's not spend time explaining this, but AutoML gives you all of this. Look at the little trophy here. It does select my champion. It recommends a cat boost classification. Great. And then I have all of the metrics. I have the area under the curve. This is it. How well the model will predict the true class, meaning how well the model predict the people that will have cardiovascular disease. This is my rate of true positive, close to 80%. Rate of true negative, 96%. This is pretty good. Coming up in the future, I know it's in the roadmap. They'll have a way to balance between these, because sometimes which one is better? Well, it depends I think it's better a true negative. If I say you're not gonna have it, I better be right. If I'm saying you haven't and you don't have it, is not as bad, because then it means that you took care of your health better. So this is good, because true negatives should be, for this particular case, should be higher than the true positive. I mean, you should uh, um, deliver, or we should adjust for that. That's what I'm trying to say. Great. Now, can I use it? Not yet. I need to deploy it. Once I deploy it, then we can use it. So deploy, you basically click the deploy button right there. You basically have to provide a name, that's all. Where you're deploying, then you deploy. By the way, you can do as many experimentations in Qlik Cloud as you want. Deployments are limited based on your license. Basic license, 2 deployments. So only the module to actually, okay, this makes sense, I want to deploy to production. You can purchase more in parallel. If you want to, I want 5 more deployments, 10 more deployments, you can purchase separately.
Yeah.
And
And can it, I know that we talked about that before in the other meetup. It's also interesting that you see there's the small enable real-time API access. That means you can consume this model. Correct me if I'm wrong. Outside Qlik, correct? You can provide through endpoint API this model to other platforms, or it's just to consume it inside the automation. How that works?
It's a deployment, and then you can consume inside an application, an automation, but it's a deployment.
Okay, but also external tools, like if I create a custom .NET application, can I use this endpoint?
Yes, so that's the real-time API. There's a real-time API. I'll show you that. I'll show you that in 30 seconds. So let me deploy. Deploy is quick. So it basically takes the train module, and now done. Let me open it. So here's my deployment. And I can use it in many different ways. This is great. I can use it in many different ways. One way is to create, and this is just a summary. One way is to come here and create a prediction directly in the deployment. So I can come here, create my prediction. I need to find a data set, like it's not in my training data set, and a new data set, a new file. And by the way, that file can be a file, let's say, that I update every week, every day. So we'll always use the same file, and the file that will only have the records that I'm trying to predict. So let me find this one here. I will clear the spaces, and I'll find. Actually, let's do Framingham. I have other Framingham. I mistyped probably Framin. Okay, there we go. And I want Framingham validation. That's probably the one I want. Let me see. That's a different data, different patients. Okay. Age range. Oh yeah. Okay, that's fine. I think we're good. We have a few errors. Glucose range. So the deployment will find fields that do not match, but it's just a warning. I think we'll be good to do this. Name your data set. How I want to name my prediction. So let's say I want to save as a Parquet file. I want to call it Framingham. Let me call Framingham meetup prediction. Something like that. It could be Parquet CSV QVG. Confirm. And then what files do I want to save? SHAP, I want to explain what SHAP is, but that's an explanation of the prediction. Why the module make a prediction, a certain prediction. Okay. And I have two different flavors of SHAP. There's a SHAP and coordinate SHAP. So basically the coordinate SHAP is the SHAP file, but with a cross table. I prefer the coordinate. It's easier to use it because this SHAP will have different columns. For each feature will have a column, but I prefer as a row, so we can put in an object, we can select. So I prefer this one. This, by the way, this is new. Before we only have this, and I have to do a cross table every time. Now they listen to us, as they always do, and we have this. Want to save the errors? Yeah, it's a good idea. Apply data set is basically a copy of this data set. So I want to copy my data set. I don't think I need it, or maybe I need. Um, what is my IG? It doesn't find an IG, so we create an IG for me. There we go. I can simply run this prediction one time, or I can create a schedule. Oh, I want to schedule this every whatever days, or actually this is daily. Let me do monthly or whatever I want to do. So you can create a schedule to run it, okay? Or you can run just one time. Let me just run one time. Save and predict now. And also you run, and it's running. It gives me the warning, but it's fine. I have another. I have an application that I'll show you that have all of these ready to go. Now, this is one option. Option two, I can, if I want to use externally, or even let's say in another environment, I can use this real-time prediction API URL. So you need for that a developer API key, which you get. Let me go to, actually is administration. So you need to go to the QMC administration, and you need to go to API keys, and you need to create one API key for you. So you create one API key for you, so generate new. You need that API key to authenticate, and you need this key. So this is basically a REST API. You input the data for prediction, you get the results. This is an REST API. You pass as a JSON format. So in the future, we're planning to do some like presentations, webinars showing how to do this in Python. Run a Python consuming this. In the future, if we get like enough people interested, then we might do it. All right. So there's another option. Those are the only option? No, I can do automation as well. Now the deployment is a resource available in the cloud. I can use it. So I can use it as an automation. So let me find. I do have. Let me get my automations. This one. Yes, I do have. Is this the one? I think so. I have two users because sometimes I need to test how a user with less access will see things. Okay, and I have the AutoML. You can tell that is
I see.
that
From in Python automation integration.
yeah, that's the one. No, that's I love automations. Dun, dun, dun. That's not the one that I am. Let me. I think is readmission. This is a different one. That's the one I want. This is not the one using the data we have, of course, because I just created this data. But let me.
I think you can open from there. Yeah, you have to go to your hub.
Yeah. It's not in administration. Oh yeah, I was in admin. Oh, what I'm thinking. It's not here. It's
analytics.
Yeah. I was in the wrong location. Analytics automations. There we go. Now I can find it. There we go. This is all new interface, so I'm still adapting, guys. Sorry. Reload hospital readmission. I think that's the one. Okay. So this is a one that we use for hospital readmission. So we reload applications, prepare the data, and look at this. So we got data. So it's an automation that at the end of the day runs. So this is deployment. See, deployment IG runs the prediction, and once I run if I run the prediction here, it means I have set up this. So then you basically run this on demand and will save a file with my predictions so that I can consume it. And then I'm running the application that shows that at the end. Okay. So that, and it does a bunch of things. It runs all the automations. It sends a Teams message at the end of the, once this is completed. This is another way. Or if I have a Qlik application, so let's say I do a new Qlik application here, and let's go Meetup CVG predictions. I have the option okay, load script. I have the option to, if I'm running this on a schedule basis, just load the files. Or if you go connection, you can create a new connection, and look at this. There is AutoML. Where are you? AutoML. So, or I can create a connection to AutoML, and these are all my deployments. So you can pick a deployment and create a connection. So you have all of these options available to you. We'll take more time to show in detail all of these. So let me jump to actually showing an application that I have already built here. But before I do that, let me go to my final slides. Now, let me maximize this. Now, remember the AutoML before I deployed that shows all of those mods, all the algorithms, and how they were, like one was better than the other. How it does it know? Because there's something called model scores, a different methodology to score a model, to know how well a model performs. So those are model scores. Again, this is the book that I wrote, and other sources on the internet as well. You can learn about these, the different types. But this is how it does it. Now, if we back to AutoML, I show you that, oh, the stroke is the most important feature, and this is the second one, etc. That's based on different ways. There's different ways to calculate that. In AutoML, they show two ways. One is permutation importance. The other is SHAP importance. I also have ebooks about SHAP, by the way, and it's all at the end of the presentation references if you want to download and read it. But AutoML does not export permutation importance, only exports SHAP importance. What are those? Very briefly, permutation importance is evaluating how important is each feature, each column, each field to the prediction. How important is this? If I remove this field, does the model still predict well? So permutation importance is, evaluates that. How does it evaluate it? It's very clever. It takes the values within the column and it shuffles them. So it's wrong value, but it shuffles them and see how that affects the prediction. If the error increases too much, then this is important, because if I mess up with this data, then my prediction is worse. So then this is important. But if this is a column, if I shuffle them and my accuracy doesn't change much, this is not important. So that's how permutation importance does. It shuffles the values within the column. SHAP importance, it removes columns entirely to evaluate importance. It's more complicated than that, because it does like in groups, in different ways, in different orders, multiple times. But it's the most accurate way to evaluate how important each feature is to the prediction. And AutoML export that to us. And I think that was, my last slide. Now, let's go to my final presentation, and then we'll bring this back home. I have already an application for the same data set, for the same prediction. Let me search for Framingham, which is this one here, just to show you how it is done and what is the importance. I did multiple things for this data set here, because I use this for multiple different demonstrations. But it's the same data. It's the same data set, Framingham, and we predicted the same thing: cardiovascular disease. And there's other things here, like we're doing hypothesis testing, etc. But there's a different topic. What I want to show is the actual prediction. So, we're prediction for every single patient, the chance of that patient developing cardiovascular disease. And And then, because I have that for every single patient, I can plot it in any way I like. I can put in any charts I like. Let me show this one first, because this will make things much, much clearer. But having the prediction, like every single patient, you have this probability. You have 90% chance of having cardiovascular disease. You have 80%, 50%, 20%, whatever. Giving for every single patient is good. However, if I only have that, it does not help me much. I need to know why the model thinks that patient will develop cardiovascular disease. So then I can talk to the patient and say, oh, listen, if you do this, this, and that, you might avoid that outcome. So that's what the SHAP distribution, the SHAP value does. The Shapley addictive explanation, that's what it means, the SHAP. Is the transparency of the module, is the why, is the prescription of that. So, well, the most important one is the stroke. The patient had a stroke or not, there's a high importance. If the patient was hospitalized for a specific condition, is another one, have angina, etc. So these are the three top ones, and then the systolic blood pressure is important, the sex, age, less important, but also in the top 10. Okay, those are the most important features. However, and by the way, if you go to AWS, that's all they provide. It's all they give it to you. It's good. However, what does it mean? What does it mean, like blood pressure? What levels? Should I increase, decrease? What does it mean, the hospitalization? If I have more hospitalization, maybe the patient is taking care of, so they have a lower chance, they have more hospitalization, have a higher chance. I don't know how this actually impact that prediction. But Qlik AutoML gives you that per row. And the SHAP value, this is an aggregated chart. You can see in detail. And I color coded, so everything that is below 0, it means it decreases your chance of having cardiovascular disease. So these patients, the value of stroke decrease their chance. This patient increase their chance. And some of them increase the chance by a lot. So then you can select specific patients and see, okay, this is how it implicates. Or, oh, model is predicting that I'll lose this customer. Let me see why. Oh, it's because of the price, it's because of this. But because of the price doesn't help me. Is the price too low or too high? Because maybe it's too low and the customer thinks this is not a good quality product. Maybe I should increase a little bit. Or maybe it's too high, it's too expensive. So here I understand how. So when we name this this webinar, like to actually get insights for AutoML, at the end of this, what we mean, because then we can actually get insights. And then if you go back to the previous sheet, I can plot it, like what is the importance. I'm analyzing age here. What is the importance of age to the development of cardiovascular disease? Look at this beautiful curve. It's going slightly up. So, which is kind of obvious, but we have a confirmation. As you get older, you have increased your chance of having cardiovascular disease. We get a different feature. Let me get the glucose. How about glucose? Well, it's all over the place. Surprisingly, is not a big impactor to cardiovascular disease. It doesn't mean eat sugar as you wish, because it has other implications, but not as much for cardiovascular disease specifically. How about the high density cholesterol? Same, it's kind of a constant, close to 0. So there's a lot of insight. So I should focus on these, of course, for my patient for other reasons. For cardiovascular disease, not a big impact. But look at the systolic blood pressure. It goes up, and it really up after 140, which makes totally sense medically speaking. So then I'll focus here, my attention. Hey, patient X, let's reduce the blood pressure to this level, because then we reduce your chance of having cardiovascular disease. That's what the prediction model says. This is true insight. And it could be like to sales, to customer churn, to machine maintenance, anything you like. Okay. I could.
Quick comment about this. The blood pressure, that this is very interesting because it's one of the things that I monitor a lot, because I'm doing the TRT therapy. So then they have to keep monitoring every 3 months the blood pressure, because it tends to get higher. So you have to drink
Mhm.
lots of water and keep hydration good, because if you increase the pressure of your blood, the density, it's so increase the pressure, and you have high risk of cardiovascular problems. And that's why I'm not a bodybuilder. Yeah, I look like one, but I'm not one. That's why,
I like your self-esteem so much.
that's why a lot of bodybuilders have heart attacks. This is one of the reasons. So there are multiple ones, but it's interesting how that curve reflects that. It's very interesting.
Great. So Costa, you want to take us home?
Yes. So so these are the where you can learn more about Qlik. So you have the help.qlik.com, the community. If you don't know, the Qlik is community is the Qlik community where you can, if you have questions, you can post your questions there. You have a lot of people to help you. I'm also missing the Qlik Nation. So you have the Qlik Nation where
I
you
didn't
can.
put it because it's invitation only now. They're not accepting new members. So
Oh, that's true. That's true.
yeah.
Yes. You have Data Voyagers is our blog, and then from there you can, yes, you can find our YouTube channel. You probably know because you're watching from YouTube, so you're already there.
Subscribe.
And then, yes, subscribe there, give a like. So, I hope this will show the like on the YouTube icon. It's nice.
Mhm.
And so Igor and his department have developed some ebooks and cheat sheets. I hope I said that correctly.
Mhm.
And so you have about the Qlik AutoML, the Qlik cheat sheets, and this Sharp Values ebook. So you can find all these materials there for free. And I was questioning myself how many people are trying to say, what's the word again that you're trying to say? Actionability.
Actionability. Yeah.
Yeah,
I say that word all the time.
yeah.
Just
I,
today, it's always
I
like
would
that.
I would split then actionability.
That's a good tip. I'll try next
That'd be
time.
easier. That'd be easy for me. Okay.
Yeah.
Yes.
So yeah, so
All right.
we have this, like Mark said, the book about the shop, and then so these are the links. You can take picture and take a look at it after. Also, this is recorder, so you can go back to YouTube and rewatch it
Yes.
as many times as you wish.
And
And
join Click Meetup.
yeah, and
Very important.
I think is that we have a few extra. Yeah, go ahead.
Oh. Yeah. Just join any meetup. You'll be very good to keep you posted.
Mhm.
Right. You can talk about the next topic. Yep.
Okay, so our next, we don't have a date yet, so stay tuned. August, maybe September, we'll see exactly. We waiting for the release of Qlik Answers to make this
Mhm.
more fun than ever. So, but
Is
we're
that in
planning to
person?
talk about language. There you go.
When you be the next in person? You'll be August? You'll be this one?
Um,
Because we have.
we're planning Boston in September, and we don't have a date for the other ones yet.
Yeah. You'll probably do a
But
world tour.
so we do have online, then we have other. We did a couple in person this year, so we'll continue to do for the rest of the year. So stay tuned. Thank you again. This date is wrong. So let me go back so you didn't see
Yes.
that because we this was from the previous presentation that is wrong. My bad. So thank you so much. We have a great audience here.
Mhm.
So thank you everyone who joined. Thank you everyone who joined and stay through the end as well. Don't forget, let me go back here so you have a last chance to join our WhatsApp group. And let's continue the talk, conversation there. Let us know what you think. Honest opinion, you don't say if you don't like, you can say you did not like. Is within 2 hours. It looks like a lot. It's not a lot of time. So we try to condense a lot of information. It's like a semester
Yes.
of training to 2 hours. And if there's any specific topics you want, like a real deep dive, let us know. We can do other events in the future.
All right.
Great.
Thank you for
All right.
coming.
Thanks, Mark.
Thank
Thank
you
you,
very much.
everyone. See you
Thank
next
you.
time.
Bye. Bye.